Hello, calculus students. This is Mr. Fugay, and in this video we're going to talk about a couple examples where we might run into some challenges when performing U substitution. So we're going to jump right into it. We're going to go ahead and look at example 1 here, and we have the integral of x plus 2 times the square root of x plus 2 dx. Now remember, when we're making our choice for U, you always should be looking at an inner function since we're trying to essentially pull out the function composition. So right away as I see this, I'm thinking x plus 2 is going to be my choice. When I take that derivative, I get dx. So when I go back to look at my substitutions, we would have this, and then we would also have this substitution to perform. Now you'll notice there's an x plus 2 on the outside. Since x plus 2 is equal to u, we actually could substitute that as well. And that's actually going to work in this particular situation because I would be left with something that looks like that. Now, as you know, the square root of u is really the same thing as u to the 1/2. So I can actually merge these together to give me u raised to the 3/2 dx. And that is something we are definitely able to integrate. We're going to get u to the 5/2 over 5/2 plus c. And then when I simplify that, we would get 2/5, because dividing by 5/2 is the same as multiplying by 2/5. U to the 5/2 plus c. We would then insert our original u back in and get x plus 2. So not too much of a challenge here, just a possibility that we are actually able to substitute this u twice into the problem. But I'm going to show you something that looks very similar, but we're going to have to approach it from a different perspective. So let's talk about that right now. So let's call this maybe like 1b. I'm going to add this to your notes right underneath. So what if instead of having x plus 2 on the outside that I just had a plain old x instead? And then we'll leave this as x plus 2 dx. Okay, well, still I agree that we would probably want to make our u equal to x plus 2. And then when I integrate, we would get du equal to dx. So once again, we would substitute this out, and then we would also substitute this out. But now we have a bit of a problem, because what do we do about this x? I can't directly substitute u in because u is equal to x plus 2. And so this is where our strategy is going to come into play. If you know for a fact that when I perform this substitution, as I will, we're going to end up having an x and nothing's going to cancel, because currently right now we would end up with x square root of u du. And there's nothing I can do about that problem. Here's your strategy. We do know what x is equal to, because if I perform a minor substitution here and a minor revision, u minus 2 is actually equal to x. And that you're looking at right here, let's get the green highlighter, this could then be substituted right there. So that would now give me what? It would give me u minus 2 times, now I'm going to go ahead and write u to the 1/2, that's okay with you, du. And then from there, we still technically can't integrate it yet, but now at least we're in terms of u, and I can perform a distributing across the u minus 2. So this would give me u to the 3/2 minus 2u to the 1/2 du. Now from here, just for time's sake, I'm not going to go ahead and do the integrations, but you would integrate, and don't forget to put that plus c on it, okay? Feel free, if you want to take a moment to pause this video and try out the u-try problem number 1 on the right-hand side, and see how you do. At the end of this video, I will go ahead and show you those answers to the questions. But what we're going to go ahead and do now is we're going to jump into example number 2, the last example that I'm going to go over with you on this video. Okay, here we are again. So we are presented in a situation where we have to use u substitution. Once again, I still am going to be an advocate of looking at this x minus 4, the number that is, or the value I should say, that is inside of the square root. That essentially represents a function composition. And so when I go ahead to integrate this, we would just once again get du equals dx. So we have this right here, we have our u, but once again we have another problem. We have this x squared that we need to deal with. But what I'm going to recommend that you deal with is to do the same thing that we did in the last question, and that is we're going to rewrite u. This is going to become u plus 4 equals x, and that is what we're going to substitute in here. Now there's a plus and a minus of doing this, and we're going to go ahead and do the substitution now so you can see what this looks like. So we get u plus 4 squared over the square root of u du. Okay, so just kind of look again at the different things that we substituted here. Okay, and then we have the green thing right there. Now, the only downside with this is that we actually still have to do a lot more simplifying. There is a different way that we could approach this. I'm going to show you that alternative method after this. But what we would do in this situation is we would need to algebraically simplify this. So up in the numerator, we would go ahead and distribute or FOIL, however you prefer that. It would be u squared plus 8u plus 16 over u to the 1/2. Upon simplifying that, dividing each thing by u to the 1/2 and using law of exponents, we would get u to the 3/2 plus 8u to the 1/2 plus 16u to the negative 1/2 du. And then we would go ahead and perform our integration. Now I'm going to go through this part really fast because this is just really applying the power rule numerous times over. I should say the anti-power rule. Okay. And so we're just going to go ahead and write this out really quickly. Okay. And then you would once again plug in your u back in and get your final answer. Now I'm going to go ahead and actually show you the alternative method though real quickly. So I was just going to say plug in u equals x minus 4 to finish. Now, I am going to show you an alternative method because not every choice of u is unique, meaning there's not only just one correct answer to a choice of u. There are advantages and disadvantages of choosing different ones. What if instead we chose the square root of x minus 4? Now this might seem counterintuitive, but I want to show you what ends up happening either way. So when we do this, we would get du equals, now this would become 1/2 x minus 4 to the negative 1/2 dx. When I rewrite that, we're going to get this as 1/2 square root of x minus 4 dx. Okay, and then what I've been typically doing here for the dx substitution is to get dx by itself, we would get this. Now, this is what I would substitute here. Now, you might say, well, wait a second, this is going to create a problem. Well, here's the thing. I am going to do, and this is why this is an alternative strategy, I know what I just highlighted for you in blue is actually going to cancel out this right here. So I'm actually not going to substitute that for you. Rather, I'm going to use this, rewrite this in terms of x squared, and directly substitute it back into this. Now, as you're watching this, okay, we're going to square both sides. We're going to get x minus 4. And what we're going to do here is continue to get x by itself. So we're going to add 4. Okay? And that is now equal to my x. So if I were to do this substitution, and mind you, as you're watching this and you're like, I think the other method is better, simpler u substitution, but some algebraic work, that is all right. That's why you have choice and autonomy when you're doing these types of problems. So I would perform that substitution. I'm still going to leave the x minus 4 square root there because, as you're about to see, okay, let's go ahead and highlight what we've done here. So this is actually what got substituted right here. And now what's going to happen is the x minus 4s are going to cancel, and you're left with a much simpler 2 u squared plus 4 quantity squared du. Yes, you'd still have to FOIL this and still need to solve, okay? But this is another way that you can handle this. So you can look at the two and kind of make a decision of which one's going to be the better route for you, all right? Now, you have a you try problem number 2 as well, so I'd like you to go ahead and try this out as well, and I'll be back on screen in a moment with answers to these. All right, we're going to backtrack to you try number 1. Hopefully you've tried this out as well. Notice in this situation, we had another situation with this x. So when I did my original u as x minus 5, I went and created a equivalent expression in terms of x specifically, which then allowed me to perform the substitutions that you see up here now. And then I go through and do the rest of my calculus to get to my final answer. Likewise, in you try number 2, I do the same thing. In this situation, I did the first of the 2 strategies that I showed you, which I think was the easier route to go, which is to just use the inner function, get your dx, and then rewrite u in terms of x. I personally like this method better because it's the fastest way to get rid of the x, and then from here you're just focusing on algebraic simplification to get you in a position right here where you're actually able to do integration rules. That will conclude this lesson. Hopefully you've had a chance to try these two U-try examples, and you will see more of these embedded and scattered in practices moving forward. Have a great rest of your day, everyone.